All right, guys. So obviously in 7.1, we went through a ton of different properties of radicals, which are going to help us today when we are solving radical equations. Before we get into some examples, let's talk about kind of some general ideas, some kind of step-by-steps for how to solve a radical equation. Step number one, if at all possible, we're going to try to isolate the radical on one side of the equation. Step number two, we're going to raise each side of the equation then to the same power as what the index is. So if it's a square root, we'll raise to the power of 2, a cube root power of 3, and so on. And then the third thing is that we're going to need to check our solutions for extraneous solutions. Now the way we check that is going to be slightly different from how we checked for extraneous solutions with rationals. If you remember, we had extraneous solutions in rational equations when a solution was part of the domain restriction, where we said that x could not equal 2, but then it ended up being equal to 2. It's not going to be quite as clear for radical equations. In fact, we're going to have to go back to some of the earlier days of solving equations where you actually plug your answer back in to see if it works. So we'll be looking at doing that for each of these problems as well. Okay, so let's look at some examples. For number one, we've got 4 multiplied by the square root of 2x plus 1 is equal to 12. So first step, we try to get the radical by itself if possible. So in this case, that means dividing both sides by the number in front of the radical, which is 4. So that'll give us 2x plus 1 is equal to 3. Now that we've got the radical by itself, we're going to raise both sides to the same power as our index. Since it's a square root, that means that we are going to square both sides of our equation. Now, just like addition and subtraction are opposites, multiplication and division are opposites, square roots and squares are also opposites. And when we say opposites, what I really mean is that they are inverse operations. In fact, that's why later on in this unit, we're going to talk about inverse functions. So what that's going to leave us with on the left side of our equation is just the 2x plus 1 that was underneath the radical. On the right side, that'll leave us with a positive 9. So then in order to solve, we're going to just solve this like we would any other equation. So subtract by 1 on both sides to get that 2x is equal to 8. And then divide by 2 on both sides to get that x is equal to 4. So now comes the part where we need to check that for extraneous solutions. I'm going to do that in this gray ink on these example problems, and that way you can kind of see where I'm checking the work. So just know that this work is not necessarily part of the solving for it, but rather part of the checking for our solution. Now, it becomes important when you check your answer that you use the original equation. Do not use at like the second step or the third step, even though it might be easier, you have to use the original equation. And when we plug in 4 for x, let's see what that gives us. Inside the radical, 2 multiplied by 4 is 8, plus 1 is 9. The square root of 9 is 3, and 4 multiplied by 3 is in fact 12, so we were good. Okay. So let's move on to number 2. On number 2, we already have the radicals by themselves, so we are actually good to go there. We can now go straight to raising both sides to the same power as our index. In this case, our index is a 3. We're taking a cube root, so we're going to raise both sides of our equation to the power of 3. When we do so, we're going to cancel out on both sides the cube root sign and our power of 3. So that's going to leave us with what was left underneath, which is 9x plus 1 being equal to 11 plus 8x. So now let's go ahead and solve like we would any equation with variables on both sides. So let's maybe subtract over the 8x. That will leave us with just 1x on the left side plus 1 being equal to 11. So now subtract 1 from both sides, and it looks like x is going to be equal to 10. So once again, let's go ahead and check our work here. So let's put 10 back into our original equation. So that would be the cube root of 9 multiplied by 10 plus 1. And then we'll set that equal to the cube root of 11 plus 8 multiplied by 10. So then simplifying that on the right, or on the left side rather, 9 multiplied by 10 is 90, plus 1 is 91, is equal to the cube root of 11 plus 8 multiplied by 10 is also 91. At that point, on both sides, we have the same thing, so we are good. Really what you want to watch out for is somewhere where you're taking the square root of a number and it gives you a negative value, or maybe where you're trying to take the square root of a negative value. Those are where you can end up with some extraneous solutions. All right. For this next example, for number 3, we've got 4x minus 2 to the power of 1/2 is equal to the square root of x over 5. As a reminder, this is where we are going to use some of those properties from section 7.1, that a power of 1/2 is the same as a square root. So that would be the square root of 4x minus 2 being equal to the square root of x over 5. At which point we are now ready to go ahead and get rid of our square root signs. Since they are both an index of 2, we'll raise both to the power of 2 in order to cancel out the square root signs. That'll then be that 4x minus 2 is equal to x over 5. Now, if you're someone that does not like working with fractions, so if you don't like having x over 5, then just go through and multiply your entire equation by 5. Make sure you distribute that all the way through. That would be 20x minus 10 being equal to x. So now we'll go ahead and solve for x. So let's subtract 20x from both sides of our equation. That will give us negative 10 is equal to negative 19x. And now we can just divide both sides by negative 19. And so it looks like x is going to be a fraction, and it's going to be equal to 10 over 19. All right, so let's go ahead and check that solution in our original problem. So we're going to have that 4 multiplied by 10 over 19 minus 2 to the power of 1/2 is equal to the square root of 10 over 19 over 5. All right. So at this point, let's go ahead and simplify as much as we possibly can. On the left side, 4 multiplied by 10 over 19 is 40 over 19 minus 2 to the power of 1/2, and setting that equal to the square root of, if we take 10 over 19 over 5, that is the same as taking 10 over 19 multiplied by 5, which is 95. All right. So at this point, let's go ahead and continue to simplify, especially on this left side. Let's go ahead and subtract 40 over 19 minus 2. We're going to leave that as a fraction, which as a fraction becomes 2 over 19 to the power of 1/2, setting that equal to, if we simplify 10 over 95, that also becomes 2 over 19. And at this point, remember, square root is the same as, or power of 1/2 is the same as a square root. So we have the square root of 2 over 19 is equal to the square root of 2 over 19. And at that point, we should be good to go. Okay. So moving on to number 4, we've got the square root of 3x plus 4 being equal to x minus 2. Notice that on the left side of the equation, you already have your square root by itself, so let's raise the power of 2. That means we're also going to raise the entire right side of the equation to the power of 2 as well. Notice that that goes inside of parentheses. You have to be very careful to distribute, especially here. So on the left side, square root and your exponent of 2 are going to cancel. That's going to give you 3x plus 4. On the right side of your equation, let's write it out as x minus 2 multiplied by x minus 2. So now, distributing the x minus 2's, we're going to end up with x squared minus 4x plus 4, and now we should be ready to go ahead and solve. So in order to solve, it's a quadratic equation, so we need for one side of it to equal 0. So let's subtract 3x and subtract 4 from both sides of our equation. That way the left side becomes 0, and the right side is just x squared minus 7x. The 4 and negative 4 are going to add to be 0. So now, I'm going to go ahead and factor using a greatest common factor of x. That'll leave us with x multiplied with x minus 7. And then we can just use zero product property to say that x equals 0 and x equals 7. All right, so let's check both of those answers in our original equation. So we've got 3 multiplied by 0 plus 4 being equal to 0 minus 2. So on the left side of our equation, that becomes 3 multiplied by 0 is 0, plus 4 is 4, and 0 minus 2 is negative 2. Now, when we're working with variables, we could say that the square root of 4 is plus or minus 2, but without variables, it's just 2. And 2 does not equal negative 2. And so 0 is not going to work. This is going to be an extraneous solution. So now let's go ahead and check 7 and see if it works. So we'll take 3 multiplied by 7 plus 4 and set that equal to 7 minus 2. Once again, notice that I'm using the original equation. Before we squared anything, you've got to be careful to make sure you do that as well. On the left side, 3 multiplied by 7 is 21, plus 4 is 25, and on the right side, 7 minus 2 is 5. This time, the square root of 25 is positive 5, as is the right side of our equation, so that does in fact work, and so x equals 7 is going to work as a solution. Just like with rational equations, if you ever run into the case where there are no solutions that are not extraneous solutions, so if both of our answers had been extraneous, then you would just write no solution. But in this case, we were okay. All right, let's take a look at 2 more examples, and I think that'll be good for today. So in this next example, on number 5, we've got x being equal to the square root of 2x minus 1. So we've already got our square root by itself on the right side. Let's go ahead and square both sides of our equation. That's going to give us x squared is equal to, on the right side, just what was underneath the square root, which is the 2x minus 1. So now, if I want to keep x squared positive, let's go ahead and move both the negative 2x and the 2x and the minus 1 to our left side of the equation and get the right side of the equation equal 0. So that would be x squared minus 2x plus 1 is equal to 0. So now, to go ahead and factor that, let's go ahead and find numbers that multiply to be 1, add to be negative 2, and that shouldn't be too hard to do. That's just going to be x minus 1 twice. So then zero product property, we're going to say that x equals 1. Now, normally we would say a multiplicity of 1, but really we don't have multiplicities when it comes to radical equations. So let's check and see if it works. Putting that back into our original equation, we'd have 1 is equal to the square root of 2 multiplied by 1 minus 1, which 2 multiplied by 1 is 2, minus 1 is 1, and yes, 1 does in fact equal 1, so we are good with our solution. All right, one last problem to take a look at, and that'll be it for today. On number 6, we've got the square root of x minus 3 minus x is equal to negative 3. So first thing we need to do is we need to get our equation with the radical by itself, so let's go ahead and add x to both sides of the equation. That way on the left side, you just have the square root of x minus 3, and on the right side, you just have x minus 3. So now let's go ahead and, since we've got our square root by itself, we'll square both sides of our equation. That will take care of our square root on the left side, and on the right side, we'll have x minus 3 multiplied by itself. Now it's important not to try to cancel out the x minus 3's. It's very tempting to want to do that, but unfortunately that's going to remove an answer from your problem. So it's going to be important not to try to divide those out. Instead, let's go ahead and multiply out our x minus 3's on the right side. That's going to be x squared minus 6x plus 9. So now, Let's go ahead and get our left side of the equation equals 0. So we'll subtract x and add 3 to both sides of our equation. That should take care of the left side. On the right side, we'll now have that x squared minus 7x plus 12. All right, so we're now ready to go ahead and factor. On the right side of our equation, numbers that multiply to be 12 and add to be negative 7 are going to be negative 3 and negative 4. So x minus 3 and x minus 4 are going to be our factors. And now we set each of those equal to 0. So that's going to be x is equal to 3 and x is equal to 4. All right, so let's check both of those and see if we have any extraneous solutions. So if we put 3 into our original equation, we get the square root of 3 minus 3. Minus 3 is equal to negative 3. 3 minus 3 is 0, so that's the square root of 0. Minus 3 is equal to negative 3. And obviously the square root of 0 is just 0. So that would tell us negative 3 equals negative 3. And it looks like we're good. Next, let's try 4. So the square root of 4 minus 3 minus 4 is equal to negative 3. Well, 4 minus 3 is 1, so we've got the square root of 1 minus 4 being equal to negative 3. Square root of 1 is obviously just 1, and 1 minus 4 does in fact equal negative 3. So it turns out that in this case, we end up with 2 solutions. So it is possible to have more than one solution for a radical equation as well. All right, guys, that is all we've got for today. Now that we're done with solving, as you've probably picked up on previous units, once we finish solving, we're now ready for graphing. In fact, that is what we will be looking at in section 7.3. Until then, have a good rest of your day.